Thank you very much. So this talk has an interesting sort of history, I suppose, in that I was encouraged to write an article to do something for the Radio Society, and I decided I'd experiment with a bit of AI to do it. And the more I did it, the more I realised what an important technology this is. And as you'll see in the conclusions at the end, I believe this is going to fundamentally transform the engineering process in most engineering disciplines. So I'm going to give a little short introduction to generative AI, which is the technology, the technical name for things like ChatGTP, the generic name. I'm going to talk about methodologies. I'm going to give you a very simple application. I'm going to talk about some more complicated applications, some other tools, and a number of other use cases, and hopefully I can get this all done in time. So what are large language models and generative AI? So these are a system where you have a conversational input. They take all the English text in, and they develop a descriptive and conversational answer. It's an hyper fast-moving technology. So this slide set was out of date between finishing it about a week ago and giving it now due to the Chinese launch. So the origin of all this, as far as most people was concerned, was OpenAI launching ChatGTP in late 2022. But there are others rapidly launched afterwards, including Google's Bard, which then became Gemini application, which was clearly appeared to be a forced launch. GitHub has got quite an interesting one. I'll talk about that a bit later. It's a different model. Wolfram Alpha is another different model in that that's capable of doing computation, whereas the other systems are not capable of doing computation. They just give you an answer. They can't calculate something in the background, as far as I can see. The list is enormous, and then the one that's snuck in on the bottom is DeepSeek, which is this Chinese one that's just come out that cost a fraction of the amount to develop than ChatGTP. So is it this one? It's this one. So, as I remember, I asked ChatGTP to give me this slide. So what is ChatGTP? It's a large language model developed by OpenAI. It's based on the generative pre-trained transformer. And it's designed to generate human-like text based on the input it receives. So this human-like text we're going to use is actually code, and you'll see how powerful that is. It pre-trains on a diverse sort of corpus of text, and it operates essentially by, if it's got a word, it knows what the next word is likely to be. It's really quite a clever and approach. So it fine-tunes after a bit of pre-training, and the interface is a user input query model. It's just like having a chat with someone on a chat line. Not that I do that very often. So, it's natural language parsing. It's very versatile. It continuously learns. I'm not quite sure how much it's learning from the conversation it's having with you. Different models have different approaches, and you'll see later on why I'm concerned about that. It may generate plausible sounding but incorrect information, and sometimes struggles with complex reasoning. This is it talking about itself here. So, having asked it for that, I decided I would ask it again when I was preparing for this talk, and I got a slightly different answer. And I asked it for 2 slides. And it gave me 2 slides. It screwed up, and I said I couldn't find the file. So it very politely says, I'll generate the PowerPoint again. Let me know if you need any modifications. It's an incredibly polite system. Although the model I've got is it's like dealing with a very clever but willful junior engineer who thinks they know better most of the time. So It's an AI-driven assistance. This is what it is saying, and it did produce these slides, including the errors itself. It's used for embedded systems and microcontroller programming, digital signal processing and waveform generation, software synthesis for audio and signal applications, and general computing algorithm development. Funnily enough, they were all the applications I've been asking it for in the month before. So let's look some more. So this is, again, you'll notice, highly tailored to what I happened to be asking it to do when I was preparing this talk. We'll see what I was doing later on. But it is saying that, for example, it might identify the waveform type, define the parameters, generate the waveform, and do optimization. I don't know what I make of the fact that, having asked it twice this question, the second time it basically told me, a bit like a consultant really, you know, you pay a lot of money and the consultant tells you what you gave in the brief. So this is how I found out how it worked. This is a great book by Stephen Wolfram. Stephen Wolfram is doing his own AI system. His is based on doing computational work and getting numbers. So there's a bit of bias in the book, in my opinion. I'm sure he's quite sort of honest about that. He is quite honest about that. But what it does is it constructs sentences by concatenating the word statistically likely to follow the current word. That's all it's doing. And it applies a biological evolutionary approach by making random changes to the expected next text. So if you ask ChatGTP, for example, which is the sort of the one that everyone knows, a question, and you ask it the same question again, it will give you a different answer, and so on. And that's different from some of the other models, as we will see. But it's quite a good text for understanding how it works. Now, ChatGTP and Google do not explain how their model works. The new guy on the block, DeepSeek, does, and I just didn't have time between their publishing their paper and coming here tonight to read it. So if anyone wants to know the deep down sort of method of working of these systems, I encourage you to go and find the DeepSeek paper. But fundamentally, if you give it a word, it gets like that word game. It guesses what the next word should be. And sometimes it changes it deliberately in a sort of a biological evolutionary sort of way. It's often applied to composition problems. These are all the things you see it talked about in public, you know, like the people asking it about Tiananmen Square to sort of to check the Chinese one versus the American one, for example. The students who are using it to get their essays done. The problem with that is that it makes mistakes and the answer is often incomplete. And so the output needs checking word by word, because if you've got a bit of body of written text, every word effectively changes the semantics of any other word because it's a sort of a composite sort of body of text. And the problem with that is that you need to be an expert in the subject to understand whether it is right or not. And that's a problem, right? And we'll see how it gets to be a problem in a moment, but we'll see what we're going to do about it. But we're not going to do that. We're going to look at a very constrained problem of software engineering. In that, there is formality in the composition of the solution and the formality and automation in the verification. So the thing about software is you start off with a software functional spec, and then you write it. And you do write a test spec afterwards, don't you? Because you certainly should be writing a test spec. So you can take the software, you put it through your test specification, and you can check the quality to the quality of your test spec, because the software is going to do what it is supposed to do, and you don't need to be a subject matter expert to check every line. You know whether it did the thing it's supposed to do or not. So it's a completely different animal when we're using it for engineering generation from when we're using it for English composition or history composition or politics. So I think this is a much more tractable use case, much more tractable than the one that everyone sort of looks at using it for. So here's the methodology. It's not quite in focus, this. This is the methodology that people used to use with it. People started using. They would start off with the question, the query. They'd give it to the large language model and they'd take the output, and the output would be rubbish. They'd never seen it get it right first time. So what was happening was, any software engineers know about Stack Overflow. I mean, Stack Overflow is the place that Google takes you to when you ask how to do this strange piece of Python or this strange piece of C. All right? It's kind of where the geeks all hang out to teach each other solutions to software engineering. And there's a sort of a bit of a challenge that people would go and take a question would be asked and people would go and sort of try and answer it. And I don't sure, I think there may have been bonuses to various people for answering as many of these as they could. Well, this got a lot of people upset because what they were doing was they were taking the question out of Stack Overflow, putting it in this system here, putting it on there, and it wasn't right. So what was happening, so Stack Overflow said, we're not taking any AI generated content anymore. It's taking the experts too long to check it. Well, what happened was that Stack Overflow, this site where we were going for years and years and years, suddenly lost 50% of its traffic. And in the internet marketing model, business model, traffic is money. And there's an interesting graph you can see. The slides will be available afterwards for getting the detail. So what happened was they were kind of forced to go into business together. And I don't know whether that's why the code it generates is so good now, but they were certainly forced to go into business. So this is how you really use it. And this is just software engineering 101, right? You start off with your functional spec, you put it in your large language model, and you get some code. You did write a test spec, even if it was only a mental model of a test spec, because you presumably wanted to know whether your code worked, because I don't know how many people have ever got code to work first time. I did a very interesting Philips course many years ago, Mike, when they were sending engineers out to Holland with the two software engineers who I can't remember who they were now, but anyway, they did an exercise where they had sort of 30 really competent engineers from the company, and the challenge was to write a piece of code that worked right first time. Nobody succeeded. I think in all the classes they ran, I think one person succeeded. So you have to be prepared to test this stuff. So write a test specification. You may reasonably use the large language model to generate the source, the code you're going to use in your test model. But you, of course, now need a test specification for this to compare it, or a test to compare it. But basically, you write a test spec, you test the system according to the test spec, and you do the standard things, you get the results. It may be that you didn't get the test spec right. It may be that the results indicate that the software is wrong, and that could be wrong for two reasons. You could have got the spec wrong, which actually happens quite a lot, or it could have screwed up the answer. And quite often, there are a couple of things that it occasionally finds difficult. Compatibility problems between various versions of Python, for example, various other frameworks. But in none of the code I'm going to talk to you about here did I ever write any code. I dealt with all those compatibility problems, all those bugs entirely by having an English language discussion with the chat engine. Anyway, eventually you get the results and you're quite happy with it. So I'm going to give you a very simple, very trivial example. I said to it, please write code to run on a RP2040. That's a little tiny Arduino thing. You're going to use the Arduino IDE, and I want you to cycle through the colours 1 second at a time. And remember, this board uses this fancy LED driver. So those of you who've used Arduinos know that usually it's a pin somewhere that you connect to the LED, and it gives you, you know, the flashing sort of thing, which is the standard hello world for Arduinos. It took both ChatGTP and I a while to realise that actually there was a driver involved. And once I realised there was a driver involved, I told it that there was a driver involved, and it gave the answer. And let's give it a... So, always gives you a commentary. So the question was the question on the previous slide. Here is very well formulated code. You cut and paste that code into the IDE, load it down, and it works. So at no stage in this process did I touch code. All I did was to give the question to the AI system, cut and paste it into the code development system without understanding it, and run it until it works. And just to prove that it worked, this changes once every second, as I said it would. It's very hard actually to do a sort of decent demonstration of these systems here, but yes, it works. And once we got over needing to use this special driver, I mean, who ever heard of using an LED driver on an Arduino board? It worked perfectly. So I'm going to talk about a project I did. It's a thing I wrote up for the Radio Society of Great Britain's advanced sort of journal called Radcom Plus. The talk I gave associated with it and the article from Radcom Plus are available from this URL. And the key thing here is that this actually details the discussion stroke argument I had with ChatGTP to get it to work. I hadn't realised I'd done this like this. So here's my problem. I had two things I wanted to build. I wanted a relay controller to control various pieces of my radio station, but of course it could be a relay controller for any piece of industrial process or whatever else you want to do. So I wanted it to control some of my amateur radio station, and I had two models. I either spoke serially to an Arduino, or I spoke Ethernet packets to basically a web server relay system that are available on AliExpress and all the standard places. And the way that worked is you gave it an HTTP command, and that set the relay on or off. So that's what I wanted to do. And this is a piece of Python here that was auto-generated using the Tinker model that I press a button and various things happen. So that's what I wanted to generate. It would have taken me a long time to learn all those models and do it. So to generate the Arduino code, this is actually the code I put in. Write Arduino code that listens to the console port for packets. I use this rather strange notation here because I wasn't sure what other junk could be coming out of the serial port, so it was a bit of rather crude in signal integrity. And then where X up here is a relay in the range 1 to 4. The command is either on or off, and then set the relays accordingly. So after a few iterations and a bit of discussion, but without delving into the code, I got 70 lines of very well functioning code that just kind of worked when I typed instructions in on the keyboard. And I built the corresponding Python for it, but I'm going to look at a different version of the Python for the next piece of the talk. So I tested it by typing commands in at the console, and the code is a bit too long to go in detail here. But the article I pointed you to has got not only the code, but it's got the discussion I had, and that in itself is instructive, because you do have to be persistent sometimes with this system. But the important thing is it's still faster in most cases than writing it yourself, particularly when you get into a framework that you've forgotten. So this is a rather longer piece of description because I wanted a Python 3 script that took parameters from the command line plus an optional parameter to sort of set it up for the particular system. So they're the environmental variables. So the IP address, a key, which is a piece of the what the relay system wanted, and whether you're going to debug it or not. So a bit of validation, change the state of a relay by sending an HTTP packet, and you have to have a bit of an argument because these days everyone wants to send HTTPS, and this rather cheap Chinese relay was old-fashioned and only talked HTTP. I wasn't worried about security in this application. The program should construct a column of 4 buttons. The program will open a file, text button.txt, where on each line there's a CSV value for the label. Then the corresponding relay will turn on and off. And so it goes on. So, and a bit more sort of logic described here. So, I have this text file. It generated this automatically. I didn't specify any of that. It generated this. From the text file, it generated the behavior that this was a momentary button. You press the button and let go, and it goes back to off again. That these were sticky buttons. These are the text. So, bit of English, and it produced a sort of multi-threaded Python application that worked. And I would have spent weeks learning the framework if I'd wanted to do that from scratch, or I'd have spent forever finding examples to clone into the thing. Whereas this was like, you know, maybe an evening of a bit of discussion with the system without actually learning the details of the inside of it. Again, all written up in the thing I'm going to point you at. But it's kind of difficult and tough to show the code in detail in a forum like this. Fully functional code was produced. I used 2 different types of AI for this. So back when I started this, the only 2 really easy ones to get hold of were ChatGTP and version 3 and Google Bard, which later became Google Gemini. The 2 systems both produced fully functional code, but the style was actually very, very different. The Google style, I thought, was in those days was much more sophisticated than ChatGTP had achieved, but they were both perfectly functional, usable solutions that you could have deployed in a real application. Occasionally, particularly with a sort of multi-threaded environment, you get crashes. Now, I don't know about you, but I dread trying to do stack debug, where you get a crash dump and you've got to try and work it out. All you do is cut and paste the crash dump, which appears on the console, into the chat system, and it says, "Oh, I'm terribly sorry, I know what I did wrong," and fixes it for you. I think that's, you know, one of the most horrible problems in real-time programming is crash examination. And at least in these simple applications, it will just take the crash dump and figure it out. It doesn't always get it right first time, but you just tell it what it got wrong and give it another crash dump or give it another an example of something that didn't quite work right. Most of the reasons there's a problem, by the way, is compatibility issues, because there are multiple versions of Python, multiple versions of Tinker. When I do some of these other frameworks, there are multiple versions of those, and trying to get you can end up in compatibility hell. But you do not need to go into the software to sort it out. If you just explain what the problem is, in every one of these cases, I managed to get over those problems simply by asking it to correct the error. So these were my experiences with Chat. I was using the free version of ChatGTP version 3 at the time I did this. It took 37 attempts to get the functioning code for the Python relay application. Now, when I was writing code professionally, maybe I wasn't all that good a coder, right? But I didn't spend any more time than I would have otherwise spent, but I spent no time understanding the details, no time sorting out all those missing brackets and those missing commas and semicolons. It just gets the syntax right. code was well written, but not as elegant as I got from Bard. But this may have been the results of the debug I was doing, because I did the ChatGTP one and then I gave the final spec to Bard, and that got it right much, much quicker, as we'll see in the next slide. It was willing, if you asked it, to have another go and gave you different code. So you'll probably notice this in some of the English answers if you use it in the English, sort of text composition mode. You ask it the same question twice, you get a different answer, particularly if you answer it one after the other. It says, oh, you want a better answer than that, and it'll give you a better one. It will do the same for code, which is a plus and a minus, because if you think about it, the coding spec is not the code, because that's the output of this system. The coding spec is the text you put in to start with. And there's a whole thing which I didn't explain, which is you have to know when to leave the system. So if you get the thing to generate some code for you, and you think, oh, I know what that problem is. There's an out by one error here or something rather, and you're very tempting just to fix it to move on. But as soon as you do that, it doesn't know about that fix. And so when you ask it to change your design in some way or other, you've got to persuade it to go back and fix that bug first. So there's always this problem of when do you leave the system and when do you do it by hand. And some of the time, if I asked it, what I would do is to get it to include as comments the instructions I gave to generate the code. It mostly did this. But it's interesting that Bard never did that. So let's have a go look at what Bard did for the same application. So Bard was Google's first offering, and it was replaced by Gemini. The only one you get now is Gemini. The example had the advantage that I previously debugged it in the other system. And it produced compact, I thought more sophisticated code than for the Ethernet controller, which is the only one I tried it on. And it got it right in 7 iterations. I mean, 7 is nothing, right? 7 is the sort of you very rarely write code in less than 7 mistakes. It was very polite, like all the other systems are, but incredibly willful. In that, if I said, have another go at that, it said, no, I've just done that for you. Literally. That's what it said. I just did, that's a quote from the dialogue. And I never persuaded it to give the chat as a comment. So for a long while, this was my preferred code generator. It certainly was when I wrote about this and gave a talk about it in October. But I told you, this is an incredibly fast-moving world. I've recently been using ChatGTP 04, and I'm very, very, very impressed with that. I haven't tried some of the other ones yet. So I focused on the ones that I really started with in the first half of 2024. But there are many new ones emerging to support the software engineering industry. And many vendors are joining the bandwagon, with many playing catch up. So the style in which I was using this was in a pure generative approach. So I gave it a task and it generated the code for me. The other model that people are using is copilots. So copilots are like that predictive text you get on your mobile phone and Word and whatever you have these days that tries to write the email for you, except it doesn't get it right, sort of thing. I can imagine copilots have a huge advantage in getting the syntax right. I have not tried it. But it's not the way I wanted to go. There are other ones out there that would do a repository analysis for you. So you know when you get a new software, you're piloted into a new software program and there's millions of lines of code and you've got to figure out what the heck everything is, right? That's always the hardest problem in coming up to speed, and that takes months and years sometimes. Well, these modern systems are quite capable of taking for example, a Git repository and understanding it, so you can say to it, sort of, tell me how you do this, or take me to the thing that does that, which is massively a massive improvement in terms of learning sufficient of your way around the application to engineer it and debug it. And there are other people who are doing a combination of the two. So Git only does Copilot, but there are other ones I've seen where they do both the Copilot and the source tree analysis, and will do generative AI input. There's a huge body of sort of literature out there, mainly trying to persuade you to buy a product. But there are some other interesting use cases that I'd like to spend the last few minutes talking about. Data analysis is one I had a go at, some digital signal processing, and some hardware synthesis. Because these are all frameworks, right, that you're using. I mean, the thing doesn't care what you're trying to generate. So the radio hands in here will understand something of what I'm doing here, but I had 95 gigabytes of CSV file. And the thing that made them interesting was they were in a directory tree. They had a mixture of different CSV templates in there, and there was some corrupt data. This was basically the full set of 2024 raw contest logs that were submitted for radio contesting, and they're all available as public record on the RSGB site, and you just pull them off, and anyone can analyse them. So radio contests are when radio hams go out and they try and have contacts with each other, and the winner is the person who works the most kilometres. It's something that Mike and I spend many, many, many hours doing on occasional weekends. So what I wanted it to do, I wanted it to extract all the fields that started with 2, M or G, because I knew that call signs, which was what I was after, only started with those symbols. Then I wanted it to convert it to a canonical representation, because there were various, the call signs could appear twice in the database with slightly different representations depending on which country within the United Kingdom they were in. Then I wanted to remove all the values that didn't appear n times. Remember I said the data was corrupt, partially corrupt. So the simplest way is to say if it appears n times, where n is some arbitrary number that you decide is sufficiently good, that it's good, and if it doesn't appear n times, it must have been a guess or a failed or busted call, as we call them. Sort it and remove all the duplicates. So we were looking for duplicates, but now we want to get rid of it so there's only one instance, and apply a number of filters, which I'm not going to describe here. But the filtering used a technique called awk. I don't know whether anyone's done any Unix programming and met awk before, AWK. I find the syntax completely impossible to understand. But I say it decided to use it, it decided to apply it, and it decided how to build a cascade of filters for me. I did not do any of that. I just told it what I wanted. And then I said, please write a shell script that takes an input file, an output file. From the input, extract the number of foundation call signs. They start with this, the number of intermediates, they start with that, and the number of fulls, and they start with these prefixes, and create an HTML output for me to display. That's what I got. You can't really see this, it's not really properly in focus. But this is a perfectly fine, well-formed HTML output. I did have a bit of an argument with it because it put a stray line in here, but I just kept telling it that it was putting the stray line in, and eventually it figured out what it was. But this, I mean, I'm doing this in an amateur radio context because that's what I was interested in analysing at the time. But this is could be any form of management data that you were analysing for your work. You know, where you're tied to go and do it in Excel, which is how most people do it, but you don't do 96 gigabytes in Excel, and where the alternative is to go and get the IT department to do it for you, which it will cost you, lots of zeros on the budget, and you may or may not get it this year or next. This is sort of a standard, relatively easy sort of thing to do, providing you understand the domain in which you're programming it, and it gives you something that's directly suitable for a report. Let's give it some other things. So, digital signal processing. There is this package which is used really in the experimental world called GNU Radio. GNU Radio is a digital signal processing package where it's a library of Lego bricks, if you like, and people normally join them together with a thing called GNU Radio Companion, but that kind of requires you to know something about how it works and what parameters to set. But it's also got a command line version. So I said to it, press, I'm dyslexic, you notice all these spelling mistakes, and what I do is, these are real sort of cut and paste from the real dialogue, right? Please write a GNU Radio script to display the spectrum of the default audio input channel on this computer. So this is really out of focus. This is the text it gave me. The text goes on for quite a way, and there is the spectrum with a negative and positive frequency. I did have a problem with this. The problem was that there was version incompatibility, but I kept telling it what the errors I was seeing were, and it figured it out for me. So I thought that was a bit boring, so I gave it some rock music from my system to give it something to do. And I said, well, just to prove we could do something more interesting, continuing with the request, that was an attempt to get it to remember the mistakes it had made before. Write a GNU Radio script to display the spectrum of the default audio input channel. This is to run on Ubuntu on a Mac under Parallels. Please notch out any signals between 2 kHz and 5 kHz. And this is negative and positive frequency space, and there's the notch. I would never have known how to write code to do that. It's not my sort of discipline or area, but it did it. And I have every confidence that if I gave it more complicated GNU Radio things, like interface to a particular software-defined radio and build me a superhead or something or other, I'm pretty confident it could do it. I didn't have time between realising it could do this sort of thing and giving this talk. So this is the last example. So I thought, well, it can do that. I asked it if it could do VHDL. It said, yeah, I can do VHDL. So I said, write some VHDL code for a simple 16-bit counter. It gave very credible VHDL output. In fact, there's a friend of mine who spends his life writing VHDL code, and I showed it to him. Yeah, that's pretty good code, he says. Let me put it in a simulator. Worked first time. I'm going to get some gate arrays and try and get it to do other stuff. But here's the potential, right? Here the potential is that a software engineer, who's maybe a specialist in one aspect of the project, can do at least some level of work in another. And think of how powerful that is in a startup environment where you've only got 2 or 3 engineers in the startup mode and they have to have every skill that the entire business needs. So we need to talk a little bit about intellectual property rights. So if you're working with one of the public generative AI systems, you're creating a data leak, right? Because you're telling it about things you want it to do, and you can always glean intelligence from the set of things you're doing, right? Now, that didn't worry me because I was writing STEM sort of stuff, and I was doing research on a non-paid sort of basis. So you do have to watch out for what you're leaking. The searching and the tuning of the answer is almost certainly feeding the AI machine and making it available to others. This has moved on a bit. The solution received back may contain copyright material. Now that's particularly a problem, of course, when you're getting it to give you pictures back or English text or composition answers or something or other. It's hard to see whether that's going to happen in software engineering because there's nothing in there that a competent software engineer might not have written and probably wouldn't have seen somewhere on the internet. Of course, you could still trip over a patent. So you better see your lawyer if it's in any worry to you. But out in the research and learning sort of world, I don't think it's much of a problem. Generative AI services, though, are now sort of moved on, even since I started this talk almost. But they're being marketed with varying degrees of privacy and selected data set learning. So if you're in a sensitive industry, they will these days spin up a private instance for you and they will allow you to specify what the training is. Of course, you have to pay for the training, but you don't have to do everything on the public systems. So what's my conclusion? I think generative AI-based code generators are going to be a game changer in engineering. I originally wrote this slide, I said a game changer in software engineering. I no longer think that's the case. They are a game changer in engineering because they are a way of taking a textual description of the concept and generating something you can put into an operational system. These 1,000-line-a-day coders, we've all met the hero coders who are absolutely fantastic, usually very clever people, but you'll give them a problem and they'll write thousands of lines of code a day, and that was their sort of stock in trade. I don't think that the 1,000-line-a-day sort of thing is quite the same thing anymore, because these things generate very competent code in a really short period of time. I mean, you need to be smart to understand what the solution is, and you need to be smart to understand what the questions are, but you don't have to put a finger on a key for every single character of, what's 1,000 lines? 1,000 lines are probably 60,000 keystrokes, right? We're already at the point where they're useful in at least simple applications, as I hope I've demonstrated, and in procedure stroke function design. So a big program is lots of small programs, lots of small procedures. This thing, if you don't want the whole program designed, you can say to it, just give me a procedure. These are the input parameters, these are the output parameters, this is what I want you to do. It does it. This is an incredibly fast moving area, possibly in the hype cycle, but the evidence is that it is already a benefit in allowing non-specialists to competently solve problems that are not in their domain, and it will significantly, in my view, improve the productivity of the existing specialists. So I'll put it for questions, but I will note that in the slide deck there's a couple of things here. There's my email address. These are the two systems I was using, but I wrote about this in an article for the Radio Society, which describes my early stage attempts at generating it and the discussions and the arguments I had with the system in some detail. That's available on here together with an earlier version of this talk, but the article is there for anyone to read. So thank you very much, and are there any questions?
Who would like to ask a question? Here.
Yeah, go ahead.
Okay, can you hear me? Yes. I'm a STEM ambassador.
Yep.
I go into primary schools and so on. I talk about future job form. I say, yeah, we certainly need engineers. Oh, and by the way, IT will always be a job for an IT person. From what you say, though, I shouldn't be saying the second. I should be saying you'll be looking at things like this. You needn't learn Python or become experts in programming.
Well, so this is about, what does this mean for people starting their career in software engineering, right? It's going to take a while before this gets adopted, and there's going to be a huge amount of legacy code, and these tools will help you work with the legacy code. I think I pointed out that some of the suites that are better at doing that than others. But I think there is a danger that people who have made large sums made their career on being specialists at the detailed code input are going to find a challenge to that in the long term. So, I mean, why would I write some of these procedures and code the hard way when I can type in the instructions and get the machine to do it? But I don't know where this is going to end. So as I was sort of driving down here, I was thinking of the people who have made a career in learning how to configure some of the specialist routers. I don't know whether anyone's done any networking stuff, but there's a whole load of rather interesting incantations that you need to give to routers. That'll be the same for firewalls and all those sorts of things. These tools are going to get to the point where you can specify what you want to do, and all that learning, the detailed syntax and spending your time debugging it, that's going to change, because you're going to be able to give, in my view, Cisco or Juniper or whatever CLI into these systems, or configuration of a disk array and those sorts of things. You're going to be able to deal with that in terms of, this is what I want you to do, just go away and do it. So I think, but on the other hand, of course, from a UK PLC point of view, we're potentially talking about aspects of the software industry having a tenfold improvement in productivity. And that's got to be something that we strive for as a country.
Okay, next question.
You mentioned that Bard gave you more sophisticated code than
Yes.
ChatGPT 3. Could you elaborate on that?
If you read the article, you'll see the detail. It used a more compact, sophisticated state machine approach than ChatGPT did in the instances that I did it, which was at the end of June last year. But this is moving so fast that it's hard to know where they are in terms of rivalry. But it wasn't more. My observation was it was more compact, more sophisticated, and a better state machine design. And well, that's just a professional sort of observation of the code that was generated. But this stuff is moving so quickly. I mean, I've no idea what DeepSeek will do. I did try a few DeepSeek things, and they look suspiciously. Suspiciously is the wrong word. They look very similar to ChatGPT.
Just a point before we go on to the next question. Stuart, you keep mentioning the article. It was
Yes.
Radcom
Plus, yes.
But it won't be available to most of the people.
Oh yes, it will, because
Right.
when I explained to the
Please
society,
explain how.
when I explained to the society that I was giving this talk, I got them to we put it in a different part of our website, just the article. So it's on the public-facing side of the website. The URL is in the paper. Write to me if you have any difficulty with it. And it's on a page where we are showing that amateur radio is not about Tony Hancock sitting in a corner of his dining room or something. We do actually do some quite sophisticated things, and there's some other sophisticated things going on there. I mean, one of the things that's going up there is some stuff on aircraft scatter. So yep.
So in other words, go and find the Radio Society of Great Britain website and look, as Stuart had said. Is that correct?
Yeah, but when you hand the PDF around, when you hand the slides around, it is here. Radio rsgb.org, emerging technology,
Okay.
and it's one of the articles on that landing page.
I have the slides. I'll give them to you, David. We'll sort that out. So, as well as the film, the video of this, there will be the slides in a separate place. Okay.
Any questions?
Right. There was a
There's
question.
one at the very back and one. I think you were first, actually.
Oh, all right.
Are there programming languages with which AI works better?
Are there programming languages in
Could
which
you
AI?
explain the question?
Right. So the question was: are there programming languages that AI does better? In the limited experiments I have done, the issue is whether it understands the language or not. So it understands the mainstream ones. It understands C, it understands JavaScript, it understands Python, it understands a number of frameworks. I haven't explored all the possible frameworks. I haven't tried JSON, but I bet it does. But I didn't see, for example, Rust or Ada or Chill, the old historic, in there. So it understands essentially the most popular languages. I'll bet you if you had an appropriate number of zeros in your bank balance for your company and you were constrained to write in a strange language, they would take your money and give you a perfectly acceptable answer. Because once it understands the syntax of the language, it's really quite straightforward in terms of getting from the problem to the solution. Because, in fact, you know that if many people know multiple languages and they can relatively easily move from one to the other, modulo remembering the detail of the syntax. So it knows what it knows. The best way of finding out if it knows it is simply to ask it. So go to Google Bard or Gemini rather, or go to ChatGPT and say, can you code in this language? And it will tell you, yes I can, no I can't. So there's one at the back. I think the answer is yes I do. I'll just go back a bit. You said it's as easy as writing Excel, all right? I can't write Excel. I have never, in all these years of learning to program, got beyond the trivial elements of Excel. I can't do any of that sophisticated stuff. But yes, this is going to blow that completely out of the water, as I showed with that data analysis problem I had. Now, what is this going to mean for companies? Well, one of the questions that I'd be really interested to know was how much of DeepSeek, the new one that was done for a fraction of the amount of money, but was of course number 2, right? So it already knew that the problem was soluble. I mean, you often notice this in engineering, don't you? The thing is infinitely hard until someone shows you how that it can be done, and once you've solved that problem, it becomes easy. I'll give you a real live example of that. In my other sort of professional interest, which was internet routing, we wanted to know how you reconverge the network, how when a link had changed, you got the network to come back to operating without it making a mistake and causing what they call microloops, which are where packets loop between a pair of adjacent routers. We were almost going to give up on the whole project, and my friend Mike Shand stayed behind after while we went for lunch and came back with a solution. Within 2 weeks, we had 4 other solutions to what was previously assumed was an impossible problem. There are countless iterations of this in engineering. So, where was I going with this? I think this is going to be transformative, and companies will either learn to use this, and noting that you can use it in a partial context, because if you can write procedures, then at least you didn't have to type in 60,000 keystrokes to get yourself 1,000 lines of code, right? And the people who do it will have a massive productivity improvement. Now, the things it can't do, my son who's in stock analysis tried to get it to do some database stuff and found he couldn't get it done. But I've got this other saying, which is no one made any money betting against the software industry. If it can't do it today, if there's money in it, it will be doing it tomorrow. So I think, as I've gone through this, a thing that I started to do for a bit of fun, I've emerged realizing that this is a fundamental transformation of the way we do many aspects of engineering. And it's not confined to just software writing. It will affect many other things. There will be simulations generated this way. There will be, if there's a language way of, a logical way of specifying it, it will be possible to do it. And the nice thing about all these frameworks and these methods is that unlike the answer to the political question or the history question or the did Tiananmen Square happen, you can really bed this down onto hardware that actually demonstrates whether your design worked or it didn't. In engineering, it either works or it don't work, and there's nothing in the middle, and you can logically test it. And that is something that these other disciplines haven't figured out how to do yet. Well, there's a couple of things here. First off, in the coding world, in the engineering world, the corpus of information you need to feed in is much, much smaller than it is in the general case that these things were originally targeted at. All right? You don't have to give it the entire knowledge as put on the internet to do these things. You only need to give it a domain-specific piece of knowledge, and there are instances where the providers are starting to work with people with large wallets and building specialist versions of it for them, and you can specify your own training data. I mean, it's quite common, for example, if you're using it to build a chat robot to answer your customer questions, to give it a confined sort of set of data. Well, we can do exactly the same thing in programming. Although it's quite scary, some of the things. I'm giving another version of this talk to a model engineering society, where I wanted to give an example in their sort of world. So I asked it to give me a black rectangle. I want 3 circles. I want a red one, an orange one, and a green one. And I want you to go through the traffic light sequence in, and I gave it what the sequence was, 1 second at a time. All right. I hadn't said traffic light, right? It came back and said, what you want is a traffic light. And it gave me a proper picture of a traffic light, and it gave me the circles, and it was all in the right proportion, and it gave me the American light sequence. So I explained what I wanted very carefully, and it gave me HTML to draw the picture of the traffic light, and it gave me the sequence in JavaScript, all perfectly working. And I then said to it, you know what I want to do is to have a click on the traffic light to make it change, so I can change it when I want it to change. And it was a one-line change. It gave me the change just like that. Didn't have to go to the book to find out how you get click input onto into JavaScript. It just did it. So, you know, I think, I say my thesis that this is transformational. By the way, so another one of those languages it knows is HTML and JavaScript, and it does a pretty good job there. And if you think about, what do they call the RESTful interfaces, which are basically URLs, I haven't tried it yet, but I'm about to try getting it to do the relay controller as a RESTful interface in JavaScript. And I'll bet, providing I can persuade it to give HTTP rather than HTTPS, it will just do it.
So with the AI, they often use data scraping.
Yes.
So they scrape the data, they analyze it. But
Yeah.
if everyone starts using AI, do you think that there's not going to be any more data for scraping? So in the future, it's almost using itself for learning.
Okay, so this is about data scraping and whether we will basically end up with a single body of knowledge and it won't move on. I don't think it's good in this context. I can't see how that's going to happen, right? Because we're engineers here, right? We have a customer problem to solve, and we have a functional specification we have to deliver to. And what I'm proposing is we use this to get from functional specification from the customer to modular specification, but then do the delivery phase of that. Will it scrape all the code that's ever been? Well, I don't care whether it scrapes all the code that's ever been, because it's unlikely not to be able to generate the code constructs that you want, at least in all the cases I have tried. And if you want it to use an algorithm it doesn't know about, then you saw from the text description, you can tell it about the algorithm. You know, take this field, do that to it, take this other field, do that to it. So long as you can do that, then you can get it to generate it. And if that's too hard, then usually you can break these things down into subroutines and functions, and you can get it to generate the subroutines and functions and bolt them together. So I think the guys who are more in trouble are going to be the people who want it for generating political papers or their English homework or those sorts of things, or writing management reports or doing analysis of the market and their industry. But I'm not interested, but I'm not advocating in this talk its use in that context. I'm advocating it as basically an engineering accelerator in the same way that compilers were an engineering accelerator in a land of assembly language. And circuit diagrams were the standard way of designing integrated circuits, and now we have VHDL, and I'm sure we have automatically synthesized VHDL, not my area, but I'm pretty certain that that's the way of the future.
Okay, I have a question, Stewart.
Sure.
It's on the question which you touched upon of basically the security
Right.
of AI, if you like,
Right.
for intellectual property, but in fact also in a different way, because you mentioned that you automatically, the questions you ask are fed into the database,
Right.
so they become available. But also later on, the solution, and this is the question, the solutions which you come up with, are they fed back into the database so that
The answer is
AI can learn from experience?
So the answer is it depends. So on the public systems, which is where I've been trying to sort of learn and experiment, I believe that yes, this is all contributing to learning. That's one of the reasons why they made the public solution available, partly to get their system tested, partly to increase the corpus of knowledge. At least I suspect that's what happened. But now you can get private versions of this. So if you're in defence, for example, I believe you can buy a private instance of this software running on a private instance of software, private instance of hardware. So you're not going to leak everything out. So at least that's what I imagine is going to happen. I'm certainly understand that you can have private instances and the data can be constrained. In Git, you can subscribe at different levels, and the stuff is can be maintained privately or put in the public domain, but that may or may not be a sufficient security level depending on what your application is, who your customer is, and what your constraints are. Yep.
Okay.
One more? We've got time for one more? It's up to you.
Is it possible that this will make programming obsolete?
Sorry?
Is it possible that AI will make programming obsolete in the sense that...
Will AI make programming obsolete? My thesis is that systems engineering will be around for a long time because someone has to go and talk to the customer, find out what the customer wanted, and design a solution for that. So it depends what you mean by software engineering. I think getting from a text functional specification to an instance of a procedure, I think that's going to change. But there will still have to be people who convert the customer requirement to a customer solution. And if you think about things, that's this is just changing the abstraction layer. So what we've been doing for the entirety of humanity is to work in more and more sophisticated abstraction layers, because that allows us to solve more and more complicated solutions with the relatively limited, in inverted commas, human intellect. And the reason that we can solve things that we couldn't possibly conceive of solving many years ago is because we work at a different abstraction layer. And so what this is allowing you to do is to abstract away getting from requirement to running code in a way that compilers meant that you no longer needed to write every line of code, or before that you needed to set the switches however you needed to set them. So I think software engineering will take a different form, but I think software engineers as a collective will be far more productive, and there will be changes in the jobs. Some of the jobs will disappear and other jobs will become much more efficient.
We have done what we would now like to do, is to thank Stewart for an absolutely riveting talk, quite frankly. It's really right at the leading edge of technology, and it's involved a lot of technical things. So, but before I ask you to put your hands together or shout applause or whatever, then we like to give you a little memento.
Thank you.
First of all, that's a certificate, which when I've signed it, which I'll do in a minute. We'll actually, you can show to Jean, your wife, that you were actually here, not somewhere else. So anyway, this is also just a little bit of advertisement and something useful, a pen.
But I'm trying to make these obsolete.
Thank you, thank you.
Thank you.